Now, my objective for the next 18 minutes or so is to ensure that everybody takes back a story that talks about how space plays a role in all our lives. Now, all of us have used Google Maps, GPS, to find direction for our day to day work. I'm trying to use my field of space to see if people can use that to bring some form of direction in the way they look at life and they go ahead. How many of you have seen the movie Martian? By a show of hands, quite a few. Beautiful movie. I think it did good justice in bringing Mars or space back to our living rooms and make it part of mainstream discussions. And that is where scientists somewhere fall behind in taking the general public along in this journey that we are all really part of. And the way I look at it is that the Earth is a spaceship. It is a moving object in this universe, right? And we're all astronauts in that sense. We're all part of this spaceship. And there are no passengers. As this saying goes, we're all crew members. It's important for all of us to be aware of the origins of this spaceship, the present bearing, and the future course of direction that it will take. And the well being of the spaceship, it's not just the responsibility of scientists and engineers, but of every single person who lives and breathes on this spaceship. How many of you have seen this image from your school textbooks, the solar system, right? Some universities also have this. Now, I have a problem with this textbook image, um, and I'll talk about that problem. We have Earth that is depicted on a similar scale of size with the other planets, right? And it's our planet, so obviously that's where the thinking comes from. How many of you have seen Lagan? I'm sure a lot of you have, right? So Earth is like Amir Khan in Lagan. It's the protagonist, the main character, located somewhere in the center, takes things forward. Now, this depiction of our solar system and the planet, I don't really have a problem with it as long as we are aware that we are in the neighborhood of giants, of unexplored worlds. And that's how we've all been brought up with an imagination that limits us within an A4 size of paper of our school textbook. But it's important to give this perspective to everyone. And it is not to take away, not to just depict Earth as a small pebble as compared to other large giant planets, and to in any ways take away the achievements and the ambitions of humankind. But it's important to have that perspective. And I'll talk about why it is so important for all of us to be aware of the cosmological size as well as time scale. Um, this was an image that was taken by the Voyager spacecraft as it was leaving the solar system. And it wasn't taken for any scientific objective, but really from a human objective. And Carl Sagan, a famous astronomer, brought this out more eloquently than I think anybody can, where he talks about this is how our planet exists. The pale blue dot suspended in a very faint beam of light coming from the sun. And all of us, all our daily problems, our struggles, as well as our previous generations, has started and has existed on this pale blue dot that is suspended mid-air or mid-space, if you may. Now, that was the size scale that we're not really so close or similarly sized to our neighboring planets. It's also important to take back the time scale. Now, all of us have grown up thinking in terms of years, months, weeks, days. We have news stories that come and go, elections that come and go. And our memory span obviously is based on the events that happen around us. Now, it's important here to understand if we were to condense the age of this planet into a year, a calendar year, 12 months, how would the ages of the living organisms look? So, if you look at this image, if we were to start in 1st of January, life did not really start until the 25th of March. And the earliest form of unicellular organisms ruled the planet for a very long period of time. Then multicellular organisms came in. You had plants and animals, you had dinosaurs, and then humans. And humans have just been on this planet for 0.002% of the Earth's age. It's such a small period, a little flicker that we are on this planet, that if I was to visualize this and portray it, I don't know if you can see the vertical line. So in a calendar year, We arrived on the 31st of December at 11:25 p.m. That is how late into the party we arrived. And who knows how long this party is going to last. But this is to give a perspective of how short lived humankind has been on this planet. And I had to magnify the age by 100 times so that it was visible in the form of a faint light, red line on that particular slide. So it's important to take back this message as well, that it's not just time, not just space, but also time that has to be kept in mind. Now, where did we come from? Who are we? How did we all start? And where are we going, right? These are questions that pertain to astrobiology, and I'll define astrobiology in a minute. To look at our own neighborhood, we've got Venus and Mars, our closest planets. Both of these planets, they are sister planets. They started in a very similar manner as Earth did. They're rocky planets. They're similar in age. Venus and Earth are, in fact, similar in size as well. But today, Venus and Mars are very different from Earth, even though they're about the same age. And what really happened? That's an open question. How did Venus become so super hot and toxic? We understand that global warming had a role to play. And what happened to Mars, which was further away from the sun? It turned into a cold, dry desert environment. So understanding the formation and the origin of these planets in our own backyard, if you were to look at it in terms of the vastness of space, gives us a perspective of even our own planet. Where did we come from? How did our planet start? And also the future, the incoming future, the way the climate is changing. There's a lot of information out there that is important for us to realize. Until the late 70s, it was common knowledge that sunlight is essential. It's a critical element for life to exist. And this common knowledge was demolished as soon as they found life not just surviving, but flourishing at the bottom of our oceans, where sunlight never reaches. It's completely devoid of sunlight, right? Right from the start of the planet. And with that information, we then looked at other objects in our solar system, because initially we were only looking as far as where the sunlight was reaching. But distant moons of Jupiter and Saturn are completely icy worlds. But it has been confirmed that underneath the ice crust, there's liquid water. And in fact, on some moons, there's more liquid water confirmed than on Earth. So there lies another open question, that perhaps life exists on these moons. So coming to astrobiology. Now, a lot of people confuse it with astrology, astronomy, space biology. To put it in a very small nutshell, astrobiology is the study of the origin and the distribution of life in the universe. It's a broad field. It doesn't only sit with the biologists, it has even philosophers, thinkers, engineers, scientists from various different disciplines that take part in this field. It's a new and upcoming field, but very much really a project that is being incorporated by most space agencies when they're looking out for life in the solar system. We look at different environments on our planet because we know of only one form of life that we have on Earth, right? And the closest place where we can study this life is our own planet. So we look at how life has evolved in different hostile environments, places that are cold, places that are really hot, places that are really salty, places that are heavily radiated by UV radiation coming from the sun and cosmic radiation from space. And within these boundaries, we try to better understand what is it that we're looking for. Because even looking for something, you need to understand what is it that you're looking for. Only then you can step out and look for it. If you're looking for an apple without even knowing what an apple looks like, you will not really find an apple. You'll find an orange and you'll think it's an apple, which might be a good thing, but this is one way to start, right? Now, taking Mars, our closest and possibly the best natural environment where we can conduct life. There's several schools of thought. People consider Mars as a dead planet. They think icy moons are more likely. But I will focus on Mars to start with because it's a lot easier and closer to our imagination, thanks to our friend Matt Damon, who was in the movie Martian, right? So these are 3 rovers that were on the surface, amongst a few. And the only one that's active right now is Curiosity, right? It's been on the surface of Mars for a little over 6 years. And it's traversed about 14 kilometers or so. Now, that's the kind of distance a human can walk in a day easily, right? Even in the hot sun of Mumbai. And that brings the challenges of robotic exploration, that there's only so much distance you can cover while ensuring that your machine does not fail and keeping in mind all the risk analysis in place, as well as there are shortcomings in terms of the experiments that you can conduct. So then the motivation is to visit environments on Earth that are Mars-like and test these instruments. And that's where my role comes in. We identify regions on this planet that will help us test our instruments. So it's not just that they look Mars-like, such as the Jordanian desert where Martian was shot, but they also offer us opportunities to access some of these different sites that help us test these instruments. To put things into perspective, now this was a very exciting discovery that took place a couple of years ago, which actually missed a lot of people. We actually found remnants of minerals that were formed at a point in time on Mars when liquid water existed on the surface of the planet. So the atmospheric pressure right now on Mars is really low. So all the liquid has in fact evaporated. Most of it has evaporated unless it's saturated with salt, but that's a different story. What is to keep in mind is that today we can find evidence of hot spring activity on the surface of Mars. And there are these nobly shaped objects, as you can see on the left, that we find on Earth in similar hot spring environments that are a product of biological activity. So bacteria actually causes these nodular shaped objects to form. And that's sitting screaming evidence demanding a future mission to go back to Columbia Hills on Mars and look at them again and investigate them for perhaps finding biological evidence that perhaps at one point there was in fact life independently evolved, or it could be something that's connected with the kind of life we know. So lot closer to home, in Ladakh, we have very high altitude, cold, dry environments that actually also have hot springs. And these hot springs are unique in Ladakh because they exist at really high altitudes, and water tends to boil at lower temperatures in lower atmospheric pressures. So it's a lot closer. The atmospheric pressure of Ladakh is a lot closer to what existed on early Mars. So the kind of chemistry that we see in those hot springs is akin to what existed on Mars. So that's the first point. And there are also a lot of interesting minerals that we've found in Western Australia, where the oldest form of life has been found, bacterial colonies called stromatolites. And we find a connection between hot springs, ancient hot springs in Western Australia and India by boron, which is an element which connects these two things. So there's a lot of interest amongst astrobiologists to go to Ladakh, pick up samples, look at the crusts, and also analyze them. So I had led an expedition from NASA Spaceship Bound. It was a science education expedition where we had Indian as well as foreign collaborators working at these sites and identifying what can be done and scoping out an astrobiology roadmap to take things ahead. Even closer, how many of you are familiar with Lunar region in India? So Lunar is an impact crater site. So close to 500,000 years ago, a 100-meter sized object entered the Earth's atmosphere and crashed into the Deccan Plateau, creating a 2-kilometer wide impact crater. Now that crater is very similar to a lot of craters that we find on Moon, on Mars, elsewhere. The reason why craters do not stay preserved on Earth is because there's a lot of environmental activity, there's weathering, and that's why over time craters get filled up. But this crater was formed in basalt, which is a kind of rock that is really hard. It's commonly found in other rocky planets, and it has stayed well preserved. It's also relatively age-wise new. So even 500,000 years, geological time span is fairly recent. So it's a unique crater in the sense that it's well preserved. It has its features in place. It also has a drainage basin, a delta, right adjacent to it, just like Jezero crater on Mars. And why is that interesting from an astrobiology perspective is that a lot of sediments that get flown in through the water body collect inside the crater. And on Mars, at one point, when we had standing water bodies, a lot of these sediments from around the crater came in and settled in and deposited. And what makes it even more exciting is that next year, we have a rover mission from NASA that will be visiting and landing inside Jezero crater, right at the toe of the delta. And its task is primarily to look for signs of life It will be analyzing some of the cores that it will take, so samples that will take, subsurface samples from that delta, and it will be looking for any form of signatures of biological activity. And Lunar Crater in Maharashtra, close to Aurangabad, is one of the only accessible sites on our planet where we have a drainage system right next to it. So just a few months back, I was fortunate to go with my team and visit that site. It has been well studied from a meteor science perspective, of impact cratering perspective, but we're looking at it from an astrobiology perspective, a training ground, if you may, where scientists can go in and understand how is it that they want to approach sites on Mars. So it's a lot easier to do those things right here on Earth before you go elsewhere. Just like when you go camping, it's a lot easier to pitch and practice putting up a tent in your backyard before you head out, because it's going to be quite difficult if you were to do that and not know how to do it. So that's where an analog environment comes in, a Mars analog environment comes in. Now that's the science part and the research part, and I hope I haven't put a lot of people to sleep already. But here's the main objective of why I'm here. It's to understand and reflect on where does society fit into all of this, right? I spoke about all of us being part of this one mission that we're all on. We're trying to find out how is it that we can all contribute to this. Now, it depends who I'm speaking to. For the general people, it's important to get the young ones, make them aware of the hard facts of the universe, put it out there in front of them, show them the scale of sizes like I've shown it to you, and the timings that we have. And studies have shown that incorporating studies about the universe, or just basic information about the universe, in formative years helps improve their emotional intelligence and also promotes social cohesion, where they're able to better respect the long-term and larger issues at hand and not focus on some of the local problems or the differences that exist. And I think that's very important, to catch them young, to at least make them aware of these things. And later on, it's their call. So no one is forcing it down to them, but have them aware of these things and go beyond traditional education, talk about these things. It's also important to differentiate between science and pseudoscience. And I think that is, in many ways, a need of the hour in this country and many other countries. That just like you've heard of fake truths or fake information that gets propagated, science also suffers from that, where a lot of information in excitement, innocence, or perhaps for devious motives gets put forward without the backing of a serious scientific investigation. For various means. It could be for gaining social media points, or it could be for financial reasons. So astrology, superstition, black magic are different from astrobiology, and it's important to put the word out there. Conspiracy theories, speculative studies, they are very different from the work that my colleagues and I are part of, where we are ensuring that the work has a logical flow, it's open to change, and there's scope for improvement at all times, which unfortunately a lot of these theories and pseudosciences do not have. So it's important to think, and I think with my talk, if people are already pondering about these things, it's a win for me, because that's where it starts, with the thought. So it's important to think and share information based on the knowledge that you've just gained. To be proactive, if you're a student, do not ever feel that you need to be at a certain level of your education or work that you can join in. I'm an engineer by background. I stepped in quite early. I was doing my master's when I got into astrobiology, but I have colleagues who have mentors who are undergraduates, even in India, who are part of astrobiology projects at different levels. And this is where astrobiology really needs fresh minds as well as people from different disciplines working together. It's not a luxury that we would like to have, it's a necessity. We cannot do a large-scale exploration of a zone unless and until we have experts from different fields as well as interns from different fields. So feel free to reach out to people in the country to do research projects. And for the general public, it's important to engage, and just by being present in this audience, you're already part of this process. And it's important to manage more and more discussions with scientists and engineers and have a discourse with them about where we can take and go ahead with these things. I will end with an image of the Yeti Crab. How many of you have heard about the Yeti Crab? Aha, no one. So I get to introduce the Yeti Crab to you, apart from the two of you. Yeti crabs were discovered just a few years back. They are furry-looking crabs cousins of the crabs that we find here in Mumbai, but they live in frigid, cold waters. And that's what makes them really, really different. That how are they able to survive in the South Atlantic Ocean where they have been discovered so far away from the equator? And there's a theory that says that they, in fact, formed and they found at the ocean floor around hydrothermal vents. So that's where they get their heat. So the hydrothermal vent is just like a hot spring on land. You have a hole from which you have gases and liquids coming from the mantle into the ocean, so on the ocean floor. And the temperature inside those vents is obviously hundreds of degrees Celsius. But around them, it's surrounded by water, which is really cold. And between the two zones, you have a habitable environment, which is conducive for life. And the life density per square meter is much more than you find on the land. And that is what is interesting to see, that even in that hostile environment, you can actually have. And there's a symbiotic relationship where the crabs have bacterial colonies living on their backs in those furry things that you see right behind them, and they feed off them, and then the bacteria rolls off, and then the crabs feed on them. And these crabs live as colonies, and they do not move, unlike we see crabs over here running around. They live singularly located in their zones, away from all of life on this planet, completely oblivious to anything that exists around them. That is their universe. Which brings me to my last slide, that how different are we from these Yeti crabs? We're living on our planet, in our little habitable zone, so indifferent, so caught up with our daily lives, not aware of what is around us. And this is not a gospel where I would like to preach out, but we're all part of this process. It's an inclusive process where we should all be part of this healthy discourse to take things forward. And I really hope that we look at astrobiology as a way of thinking more than just a discipline of science. Thank you.